The question we are solving now belongs to test series 1. It is of network theory subject. In specific, it belongs to transient response analysis. This is a common data question. As per the question, there is an electrical network given which contains two voltage sources, one of which is of potential 10 volts and the other one is of potential 5 volts, and there are totally 4 resistors, out of which 3 resistors have a resistance of 10 ohm resistance and one resistance has a resistance of 11 ohms. Please note that there is a capacitor which is of capacitance 1 farad and the potential across the capacitance is measured as ECE of t. There is a SPDT switch which is moved from position 1 to 2 at t equal to 0. The current through the 10 ohm resistor is written as IR2 of t. We need to find IR2 of t for t greater than or equal to 0. Please note that for finding IR2 of t for t greater than or equal to 0, we need to find Vc of t, which is dependent on Vc of 0 minus and Vc of infinity. So first we need to find these two quantities, then find Vc of t, then IR2 of t. So for finding Vc of 0 minus, by drawing the equivalent circuit at t equal to 0 minus, we see that at t equal to 0 minus, the capacitor can be replaced by a open. So Vc of 0 minus can be measured as the drop across the 10 ohm resistor that is marked. So by voltage divider rule, we can see that Vc of 0 minus is 10 multiplied by 10 divided by 20, which is equal to 5 volts. This is because of the reason that at t equal to 0 minus, capacitor would have reached the steady state, hence can be replaced by open. Now for finding Vc of infinity, that is as t tends to infinity, again the capacitor can be replaced by open, but please note that in this case the switch is in the position 2, and as t tends to infinity, capacitor would have reached steady state, so it can be replaced by a open. From this we see that Vc of infinity can be written as the voltage source itself. As the capacitor is open, there is no current through the circuit at t tends to infinity. Hence, the drop across the 11 ohm resistor is 0. So from this we see that Vc of infinity is equal to 5 volts. We know that the voltage drop across the capacitor can be written as Vc of t is equal to Vf plus Vi minus Vf multiplied by e power minus t by tau. Here Vf is equal to Vc of infinity is equal to 5 volts and Vi is equal to Vc of 0 minus is equal to 5 volts and tau is equal to RC, R equivalent multiplied by C. Here C is equal to 1 farad and R equivalent is a resistance as seen from the capacitor terminals, which is 11 ohms. This can be written as 11 seconds. From this we see that Vc of t is equal to 5 plus 5 minus 5 multiplied by e power minus t by 11, that is equal to 5 volts. From this we see that IR2 of t is equal to IC of t is equal to C multiplied by dVc by dt, that is equal to 0 ampere. From this we see that IR2 of t for t greater than or equal to 0 is 0 ampere because of the constant voltage across the capacitor. From this we see that the correct option which represents the IR2 of t is D.